Hi, I'm Ben Greer, and we're here at Texas State Technical College in Waco. I'm here with the laser department, and we're going to be covering Laboratory 2-4, measuring the output of a CO2 laser. Let me give you a quick overview of the equipment here. These are all of our manuals for all of this equipment. This is the Diamond C30 air-cooled CO2 laser. It runs on 48 volts DC, 12 amps of input current. This laser has a maximum CW output of 40 watts, and it's in the infrared range. The wavelength is 10.6 micrometers. So you're definitely going to want to have safety glasses on and make sure that your doors are closed, that you have a fire brick in the beam path, and that no reflections are being pointed anywhere else in the room. This is the power supply for the Diamond C30. The Diamond C30 requires 48 volts of DC and 12 amps of current. Here on the back of this power supply there's a current adjustment knob, and when you have this on you need to set up a DMM and measure the output voltage and turn this screw until you get 48 volts, otherwise the laser will not power on. This is the PC1G laser controller. It's used to control the power output of the Diamond C30 in the operating mode. This is the DC power switch. It's going to be off when the laser is powered off. This is the mode switch. You want it in CW mode for this laser. The control source switch will always be local for this laser. And the local function switch will be in CW initially, but when we move to the gated CW portion, we'll switch this over to external modulation. And here we have the signal generator. This is going to be used to modulate your CW output when we switch to gated CW mode. The hertz setting will be at 15 hertz, and you're going to want a square wave input signal. The output jack that you're going to use is the TTL CMOS jack. We have a splitter attached to the back. The signal is coming in the channel 1 of this oscope and also going to the PC1G controller for whenever we gate the CW output. This is our oscilloscope, and as I said earlier, channel 1 is the signal generator's output signal, which you're going to be inputting into the laser. Channel 2 is our detector for when we go through the gated CW portion of the lab. Okay, this is the CO2 laser power meter that we're going to be using for this lab. We'll be measuring the CW output power and the average power when we move to the gated CW mode. You're going to, just as a reminder, you're going to want to make sure that your wavelength is correct. And to set that, you can go to the menu and go to wavelength correction. If you want to get back to the measuring screen, just press measure. And then you want to make sure you zero it out before you put it in the beam. Now it's time to turn the laser on. So the first things first, make sure that you have your safety goggles on, because this beam will definitely damage your eyesight. And it's better to look funny for a second than to be blind for the rest of your life. Alright, so now it's time to supply voltage to this laser. This power supply accepts 240 volts AC, two-phase. Now from this point in the video, you're going to have to endure the laser's 4 cooling fans turning on, which they're quite noisy. Alright, now we're going to turn the DC power switch on, and you need to wait 42 seconds before you can adjust the power. Okay, now we're going to adjust the power. Turn the knob clockwise and watch the fire brick until you see an output. Okay, now you're going to zero out your CO2 laser power meter and move it into the beam path. Now you're going to adjust the laser power knob on the PC1G until your power meter reads 10 watts. Remember that we're still in CW mode. Now we're going to measure the beam width. I'm going to take this burn paper and move it horizontally through the beam 3 times in order to get a good representation of the beam. Now I'm going to measure the middle pattern because it's the most consistent. I'm going to be measuring from the 2 outside white lines. I'll take 3 measurements for consistency. 0.25 centimeters is my first measurement. Another 0.25 centimeters and 0.30 centimeters. Now we'll take those 3 measurements and calculate the average diameter of the beam. Using the diameter, we'll calculate the beam area in centimeters squared. And taking our power measurement from earlier, 10 watts, we'll divide that by our beam area and come out with an irradiance in watts per centimeter squared. Okay, now we're going to switch the laser from CW mode to gated CW mode. Take this local function switch and turn it from CW to external modulation. At this point, you want to make sure that your signal generator is set at 15 Hertz. Now we're going to measure the average power of the gated CW output. We'll zero our meter. And move the detector into the beam. So as you can see, our average power has dropped from 10 watts to 2.88 watts. Alright, so now we're going to move to the oscilloscope and change the input signal to a 50% duty cycle. So what I did is I measured the total pulse repetition time and adjusted the duty cycle knob on the signal generator until the signal was on for 50% of that pulse repetition time. And as you can see, our average power is now roughly 5 watts, which is what we would expect to see if we're on for 50% of the time and off for 50% of the time with a 10 watt CW input. Now I'm going to take our CO2 power meter out of the beam and put this detector in the beam path. I'm going to need to turn the oscilloscope to face me so that I can watch trace 2 react to the beam to know when my detector is in the right position. So now we're going to watch the oscilloscope as we move the detector into the beam path. And once you pick up the signal, you'll need to adjust the oscilloscope so you can best see the trace. And once you have your signal, you can freeze it and move the detector out of the beam path. And from here you can get whatever measurements you need from the lab.